Our next speaker is Mr. Balaji Sundara. Mr. Balaji is a coach, advisor, and a senior product leader with over 2 decades of experience in building secure, resilient, and scalable enterprise platforms. Balaji has led several product organizations in his career, including Cisco, Oracle, Dell-Boomi, BMC, and Axway. He was a senior product leader of product management at BMC Software, where he led consolidation of service data with operational data for AIOPs. His expertise lies primarily in engaging with clients and laying the foundation for technological transitions. He is currently leading Composio towards its value proposition of AI agentic systems with the use of LLMs, APIs, and RPA. Please join me in welcoming our keynote speaker, Mr. Balaji Sundara.
Thank you, Kiran. Can you hear me?
Yes, I can hear you.
If you can go to the first slide, then I'll start speaking about.
Yeah, I will share. Yes, you can proceed now.
Thank you, Kiran, and thank you, everyone. Um, I have a bit of a cold today, so I won't be in my topmost performance today, but I'll definitely try to do this as best possible in my way and impart the webinar in a way that you can understand it. Any questions that you folks might have, reach out to me. My email is available with Kiran and along with the presentation as well. So I'll be happy to entertain questions via email and answer those questions to you. So next slide, please, Kiran. Yeah, so the reason we are seeing this pictorial is the easiest way we can understand why we need tools. The reason we need tools is because as long as humans or animals have been alive, anthropologists and archaeologists have actually figured out that a tool makes an animal or a human more powerful. A monkey, actually depicted in this picture, used a tool to crack open a peanut shell and to consume peanuts from that peanut. Humans used two stones to strike with each other and create fire. So important discoveries came along the way after the discovery of fire. Similarly, humans who have been ever innovative and ever cognitive have figured out many different tools over their lifetime to make things easier for themselves and for the prosperity of the humanity in itself. So tools actually enhanced the capabilities of humans as well as animals. And human endeavor is always has been to create tools to make tasks easier for themselves. So if we have understood this very simple fact of why tools are used, it is the same principle that applies for agentic tools to make the task easier and make the task better for AI. Next slide, please. Yeah, so before we proceed into the tool discussion, let's talk about what really AI agents are. We have spoken, I mean, several other speakers today have spoken about AI agents and AI in general. The definition that I would like to put forward is a very simple definition for AI agents, which is very simply put, AI agents is nothing but a software that actually uses artificial intelligence, essentially LLMs, and tools to accomplish tasks and goals. Goals is what everyone is after, making life simple, making life more productive by using these LLMs and tools to accomplish tasks. In the process of using these tools and achieving goals, there is memory. So, very simply put, I will say that, humans, when they use tools, there is a function of memory. The memory is essentially our brain, which is actually telling us how to use those tools. Very similarly, an AI agent will actually need to use memory and an ability to remember how to use those tools across tasks and between the different states. So memory is very, very essential for an AI agent. The next thing that we look at is models, which is how do AI agents use the models? There are many different LLM models available today, and each LLM model has its own specialty and it has its own advantage for using a particular LLM. So, which LLM to use and which model to use to accomplish the task by an AI agent? That's one of the underlying principles for using the AI models to complete tasks. And we'll see an example of this in this presentation. Tasks. What are tasks? Essentially, when it comes to an AI agent, a task is nothing but a function call. It's either like using ability to use an API, ability to use an iPaaS or integration platform as a service, or like RPA to accomplish the different tasks. So APIs have been set up for various software products. iPaaS is an integration platform as a service, which is integrating two pieces of software and those mechanisms are very useful for completing certain complex tasks that could be software to software interconnectivity that could be used by an AI agent to accomplish certain tasks. RPA is software created and written particularly for certain robotic processes for certain software that do not have an API access. So you would need to use robotic process automation to accomplish those particular tasks. Once we have these particular tools, we can use any one of these methods, which and function call to these methods to accomplish the tasks by using API, iPaaS, or RPA. What is independence when it comes to AI agents? The ability to decide on their own on how to accomplish the tasks. So, you may have all these different tools, API, iPaaS, and RPA, but which tool to use at any given time is a decision that an AI agent makes to say that I need to use this particular API, let's say Google API, to write an email to a certain user from whom an email actually came to my inbox. So it can use the Google API to decide how do I respond to this particular email and send an email back to a certain user. And the last but not the least in this particular list of items is logged errors. Logged errors are very, very important for AI agents. Why is the reason? I can explain it right now, which is Kiran, what's the disturbance on the line? Can we ensure everyone is muted, please?
Yes, yes, they have muted.
Okay, thank you.
I think just now they have joined. Okay.
All right,
Sorry for the
thank you.
interruption. Okay.
Thank you, Kiran. So logged errors are very important for AI agents. I'll explain the reason why. In traditional software, we have logged errors, which come out as like logs, error logs for software. Traditional QA and traditional customer service looks at the log errors and decides how to fix a particular problem in the software. And these are essentially referred to as bugs. Logs are very important for solving those bugs and for maintaining the software continuously. Similarly, AI agents learn a lot of things from logged errors. So it's just experience. So we are using an AI agent to accomplish certain tasks. Certain tasks might not be accomplished by AI agents, and that's what throws the logged errors. Logged errors are like a feedback loop for the agents. So using the logged errors, the AI agent can figure out what is the mistake I made and why the task was not accomplished or the goal was not accomplished. Using the logged errors, the AI agent can go back and say that this is the reason why this task could not be accomplished. Let me learn that from that particular experience. And the next time onwards, when the same task or a different task is told to the agent to accomplish, it goes back and does it in a systematic manner and does accomplish that particular task. And as you see, over time, an AI agent only gets better by looking at the logged errors and by looking at LLMs and by looking at what tasks to be accomplished and by looking at the same API and the iPaaS and the RPA mechanisms to do a goal-oriented task and keep you know everything done autonomously and intelligently and independently. Next slide, please. So then it comes to a big question that users may ask, which is, isn't this automation? Isn't this workflow? And what is the difference between automation, workflow, and AI agent? Uh, so I present it in a very simple manner here on this slide. There is fundamental differences between simple automation, AI workflow, and AI agent. Um, in its core working mechanisms, a simple automation is nothing but a rule-based system. And AI workflow is nothing but a workflow with LLM calls. So it's looking at an LLM, learning from it, and providing the feedback. And essentially through the feedback, it's working in a workflow mechanism to accomplish a particular task. AI agent is completely autonomous and has reasoning because it's looking at the logged errors and reasoning from that and essentially accomplishing the goal. So it's fundamentally different from both automation as well as workflow. The learning mechanism for simple automation is nothing but script based. Learning mechanism for AI workflow is nothing but retraining of the evolved data, meaning it looks at the data output, learns from it, and then puts that into the workflow mechanism to accomplish a goal and a task. Whereas an AI real agent is nothing but it's doing everything in real time and everything autonomously. Um, Initially, what will happen is these AI agents will use human intervention, but later on, most of these AI agents will become fully autonomous and will be working in like full real-time mode. There are certain strengths and weaknesses for each one of these methods. In automation, it's nothing but we are using a script which is very easy to build and very fast to execute. It's directed. The weakness is it becomes inflexible, meaning that it will accomplish one task, but if you think of a simple automation to accomplish like a complex task, then that simple automation does not work and it becomes inflexible because it's a complex automation then. And with an AI workflow, what happens is the strength is it's knowledge-based workflows. So it works in a workflow mechanism and it uses predefined logic flow and it tends to be very high maintenance, meaning that if certain workflow items do not work, somebody has to go back, look at it, and fix that. So the maintenance becomes high because somebody has to be constantly looking at it and making changes to the workflow. AI agent is again, as I expressed before, autonomous decision making based on rules and based on LLMs. It's high cost because the complexity of an AI agent is very high because it's actually making decisions for itself, acting as fully autonomous and with reasoning. As a result of which an AI agent working in fully autonomous mode tends to be complex to maintain. Certain examples of each one of these methods, which is simple automation, you can think of it as a process which is has a goal of like completing. And when the process actually completes, some post-scheduler tasks need to be accomplished. Meaning, let's say a process completes and in a traditional scenario, you would have to have, let's say, an email or a pager alert go out. You could use very simple automation that when the task completes, trigger an automation to send out like a page notification to someone or to a group or to an email. AI workflow, the simple example is chatbot or answer bot that is typically used today with lots of different softwares as well as web pages, which will answer questions for people if they have underlying questions about knowing about what that particular software product or that website actually does for those users. AI agent, on the other hand, as I mentioned before, is let's say you get a lot of email asking for like calendar entries and allotting time for um, meetings with certain people. Now, this can be a human task where a human looks at all those emails, scans through all those emails, and organizes their calendar by saying there's a meeting at 8 o'clock, there's a meeting at 9 o'clock, so I need to allocate some time between 8 and 8:55, and then set up another meeting between 9 and 9:55 or so. Instead of a human doing the task themselves, an AI agent could take over that particular task and set up calendar appointments to like Gmail or to Outlook or any other email program. So you could use that agent as a beneficiary for yourself, allow the agent to do the task for you so that you get freed up from the task of organizing your calendar events, and let the agent do its work. Next slide, please. Now that we have known about what an agent is and what it can do, and that it is different from simple automation, um, the immediate question comes to mind is, why do we need to look at agents, and what is the prospect of using these agents in real life? Many people have actually evaluated the market for AI agents, and the current outlook stands at, and I think this slide is from Forrester. This AI agent market, they have analyzed it to be about billions of dollars, 52 billion essentially, between 2024 and 2030. So the market is huge for this. And we are sitting here in 2025. You can see that the market is anywhere between 5.7 and 22 and 12 billion dollars in all the different fields. And these fields could be marketing, customer service, research and development, and data and technology, as well as healthcare and many other verticals. Um, and it's growing at a rate of 45% combined annual growth rate. So the growth rate is huge, market is huge, many different verticals and many different aspects of technology can be used to uh, put AI agents to work. In marketing, a simple example could be packaged goods delivery from point A to point B. Essentially, it's think of it as a supply chain, or think of it as selling goods in the market. And essentially, what happens here is, um, uh, think of a company writing blog posts for selling packaged goods in the market, and those blog posts could actually be done by AI agents just by instructing and saying, go write a blog for me. And these agents would be taking on the goal of writing blog posts for you and reducing costs by 95% and improving the speed by about 50 times, because an AI agent is doing it and a human is just evaluating that blog post and publishing those blog posts. And at some later time, the AI agent themselves actually does these tasks on under the instruction of other AI agents. Customer service, we have seen lots of customer service and customer experience agents where an AI virtual agent can interact with customers. And these things are in place today. There are certain companies who are using these agents today. And a simple example is a company called as Klarna, which has been using these agents to figure out how to interface with customers in order to lead for cost reduction in those contact center or customer contact centers by about 10 times. And if such dramatic improvement can be done in those customer contact centers, it's hugely beneficial for the company and hugely beneficial for the customers as well, because they're giving that customer experience to those customers. So there was a talk earlier today in terms of job losses. I don't consider this as a job loss, but I consider this as um, an improvement, because an AI is so much better in providing customer experience as opposed to employing more humans, training them, and helping them provide the best customer service for other humans. And of course, it will be a matter of time before everyone gets comfortable with virtual agents, speaking to virtual agents and getting help from virtual agents. Similarly, in research and development, AI agents can help in lead generation, reducing cycle time by 25 to 35% and resulting in time efficiency. And these can be done not only in for scientific purposes, but also for healthcare needs, where agents can evaluate, like let's say X-rays and MRI data, as well as look at like drafting clinical reports and drafting like clinical studies, helping doctors and nurses along the way. And I would definitely not put an, I mean, at the current time, I would definitely not put an AI agent to take on the tasks of a nurse or a doctor, because it is so much more important to have a nurse or a doctor interpret what an AI agent is saying and deliver that information to other humans who are seeking the help from nurses and doctors. And in terms of data and technology, think of like an IT department which is using AI agents to modernize its legacy technologies as well as increasing productivity. And the tune for this can be immediately visible in the task that I have done in my previous role, bringing like customer service data with monitoring data together and using AI ops technology to do the operational work of an operational person who is currently working in some kind of an operational role in a data center or in a IT operation center. So all of these examples, we could use agents to reduce the task of humans, difficult task of humans. And AI agent is actually assisting the human while the human is completing the task. Next slide, please. Kiran, next slide, please. Thank you. So the trajectory for tasks to goals is essentially we have used AI assistants in the past, which is a task-based explicit user prompts and responses, which is directed output. And those directed outputs lead to task automation for humans. Then comes the AI agent, which is goal-based, essentially saying, go do this task, and the agent actually goes and does the task automatically or autonomously. And it is nothing but decision intelligence. And that era, we are in that era currently, which is AI ops and using the data that was collected in the past to empower the agents to do the tasks that humans were doing in the past. And then finally, we will come to an era of agentic AI, which is systems of agents. How do these systems of agents work together and complete a goal or in an organization which is very dynamic? Think of like BPOs, think of like back-end processing by complex systems and complex tasks. So AI agents would be so much more important in those scenarios to achieve nothing but ROI in all of those systems. Next slide, please. All right. So this is essentially giving you a pictorial of the agent, which is essentially what an agent is. So here in this input, for inputs, we are taking inputs from structured data and unstructured data, which is essentially think of them as data that is important for those agents to act and accomplish a task. Agents, on the other hand, are using models. These can be many different models. And by model, I mean those LLMs. And it could use either, Anthropic, it could use either Gemini or like OpenAI or something. And um, use those knowledge within those LLMs, which is a superior level of knowledge to accomplish a certain task. And that accomplishing of the task is nothing but outputs that come out of those agents, which are actually scanning those LLMs based on the inputs and delivering those outputs. Next slide, please. Now, this is an example. It's a blurb of what Composio, the company that I'm advising, has built, which is we look at lots of different agent frameworks, which is towards the lower left-hand corner. And these frameworks could be from like a company called as Crew AI, which has a framework for developing an agent. It could be AutoGen, it could be Julep, or it could be like Lizard. All of them are open source models. And these frameworks could be used by Composio. We have integrated with all those frameworks. And Composio by itself eases the task of looking at the different LLM models, which is OpenAI, Gemini, Anthropic, and bunch of other models to make decisions, and that's what Composio is, the lightning bolt at the middle of the this slide, to figure out which API or which kind of tool to figure out and use one of these tools to take action and deliver that particular action. So essentially, it's the description of the line that has been put in the top of the slide, which is Composio is nothing but a tool designed to streamline and optimize connection and interaction between your AI agents and LLMs and different APIs and services. So that's the blurb on Composio. Now, I won't talk about Composio, but let's talk about all the different aspects and tools that can be used by AI agents to become even more so powerful. And also, one of the things that I want to lay down here is it's not essential to use Composio. You can, the individual frameworks can themselves, through like coding and through like design, use a variety of APIs, a variety of iPaaS, and a variety of RPS. In this, you are doing your tooling on your own, meaning you're writing the code on your own. Now, maintaining that code is the aspect that people have to think about, meaning, are you going to maintain the tool yourself, or are you maintain that code yourself, or are you giving it to a tool company like Composio to manage the interaction between the agent as well as LLMs and as well as APIs, RPAs, and iPaaS? So you would rather use the tool than develop on your own and maintain the code on your own. Next slide, please. So by using a tool, what can you accomplish? There is hallucination. It's a well-known fact that most, I mean, AI and AI agents will definitely have hallucinations, meaning that it will deliver wrong results. And it is true today, and that's the state we are in right now. And that's the reason we are saying it should be human-centered, meaning a human should be in the loop, and a human should look at the reliable connection between the interaction made by an agent and an API. Inconsistency, meaning that some of those APIs suggested and used by those agents could be incorrect and could be um, not the right mechanism. And a tool actually solves that because a tool recognizes that first. You will experience this if you actually are writing the entire tool integration mechanism on your own. And you would have to make sure that it is not inconsistent, it's consistent and delivering the right results. Instead of that, use a tool and make life simple for yourselves. Several other concerns that were brought in previous presentations. We suddenly heard about ethical and bias considerations. Um, uh, uh, a- an AI or an AI agent can make unethical and certain and take certain biases to make a decision, and we should be very very cognizant of this. A tool is definitely helpful in this area where it can make recognize those ethical unethical considerations and biased considerations to lead the AI agent to different conclusions. So prevent from that as well as make the right decisions is something that and a tool can actually help you with. And besides writing the code from scratch leads to high development and maintenance cost. I actually alluded to that in the previous slide. You can actually prevent yourself from this issue and rely on a tool which makes the right decision for you and eases the high development costs. Scalability challenges. You will see further down in the presentation how this scalability challenge can be solved by a tool. And let's go to the next slide to understand that. Kiran, next slide, please. All right, so let's talk about AI agentic tools. What do these tools do for you? Okay, so we spoke about the tools in the very first slide. Why use the tools? So in the case of AI, you are actually using the tool to simplify managing authentication and authorization. You are using the tool for managing compliance and security. You are using the tool for managing APIs, RPAs, and iPaaS. We have spoken about that before. You're using the tools for triggers, webhooks, and other eventing systems that can make life very simple for you. All of these triggers, webhooks, and eventing systems are there in traditional software today, and companies are using all of these methods within traditional software to make those software even more powerful. A tool can actually do that as well, which is plug into those triggers, webhooks, and eventing systems, and make life simple for anyone to use agents in the current mechanism and the current software status quo in the industry. A tool can also be used for managing long and short-term memory. We saw that earlier, that agents do need memory, and we'll see that further in the presentation, how agents actually use both long and short-term memory. And furthermore, a tool can simplify JSON structures and also with error handling. And we saw that earlier, error handling is so much more important for AI agents. And what do all these things, what do the tools actually accomplish? The tools will reduce the code complexity, making it simple. What we have seen with Composio is you could actually write the task and the function calling mechanism for an AI agent in as little as 100 lines of code. Uh, the tools actually make it really simple for you to understand APIs and picking the right APIs. Meaning the LLM actually goes and reads the documentation for those APIs, understands from the documentation, and says, this is the API you need to use in order to accomplish that particular task and the goal. Instead of you doing the work, the AI is doing the work for you. Simplifying the action pattern. In traditional APIs, there are many different parameters, there are many different attributes. All those attributes actually help you to accomplish the task and the goal. Do you need to use all those attributes? Probably not. So the AI makes the decision and says what attributes to use for which function call and how to use those attributes to accomplish that particular goal. Furthermore, as we have mentioned, the memory use, we'll see that in the future slides as to how that memory can be simplified for each agentic tool. And we are seeing in the pattern of making the decisions. And again, all of this summarizes down to what Steve Jobs actually said very early on, which is start with the UX. An iPhone was created with the UX, meaning a human is using the UI and can very easily figure out how to use the which tool within that particular UI to accomplish a particular task. And that's what we do today. We pick one of those, you know, um, um, tools on our smartphones and to get to whichever action, which is, do we need to go look at our bank account? Do we need to go look at a travel agent website, set up like a travel pattern and set up like a flight plan and, so on and so forth. So start with the UX and then work backwards to the technology. A tool is doing exactly the same thing, which is looking at how to accomplish the goal, working backwards and, doing all the tooling to make your agents even more so powerful. So we are doing exactly the same thing which Steve Jobs actually told many, many years ago. And that has led us humans to use devices like smartphones and smart technology and ease our tasks within the current enterprise. Next slide, please. So over here, I'd like to explain how this whole evolution towards tools actually started. Very simply put, we were actually looking at LLMs early on to look at two fundamental things, which is given an input as text and given an input as or a document, an LLM could be used um, to uh, to actually decide on what the output could be delivered for accomplishing a particular task. It's a very, very simple model, and the tool was very, very simple, where the tool would use the decisions made by the LLM um, to retrieve the answer and deliver it as output back to the user. Next slide. I think uh, I think you skipped a slide. So Okay, that's okay. I can actually continue on. Can you go to the next slide, please? Okay, so in this one, what happens is this is a slightly more complex mechanism where the input could be both text and documents. LLM could be used, and a tool could be used to deliver the right text and the right document back to the user as an output. And the database out there that's being shown is nothing but a vector database. And the vector database is telling exactly what kind of output, which is in the form of text, or what kind of output, which is in the form of documents that can be delivered back to the user. Next slide, Kiran. Kiran,
Yeah, could you please move? Okay.
I think he, I think you skipped a slide. Can you go back to slide number 13, please?
Okay, 13 slide.
Okay. So in this one, the concept of memory comes into place where the input could be your text, a document, image, or audio. You are still using the LLMs, and the LLMs in turn is using the tool is actually using the LLM and actually storing some of the responses back into memory. It's still using the generation and retrieval mechanisms from a vector database, and then making a decision to say, what kind of output do I deliver back to the user in terms of the same media, which is text, docs, images, and audio. Next slide. You're skipping a slide. Can you go to slide
Oh,
14, please?
oh, the same slide.
It's not the same slide. It's slightly different. Yeah,
Yeah,
thank
it's
you.
a perfect. Okay.
Thank you. Uh, so here you look at the expansion within the bigger box in the middle. And this is exactly what the agent state is today, where we, we put in inputs as text, documents, images, and audio. It goes into that agent body of work where the LLM is using a decision mechanism saying, am I delivering the right response back to the user as output? And that entire decision mechanism is in a feedback loop. The tools are using the LLM, the memory is using the LLM, and the memory could be like of three different types. It could be short-term memory, it could be long-term memory, and it could be an episodic memory, which is what happened at a particular given time at that particular time. So in this particular case, you could be using like a vector database as before, or you could, and this is more enhanced because now you're using some kind of a semantic database where you're actually using a meaning to providing a meaning to the document, the text, or the image or audio, and that particular reasoning or semantic meaning of that is getting stored in the short-term memory or a long-term memory. And that's what is delivered as output back to the user in the same media type as the input media type. Next slide, please. Now, this is where the whole agentic AI system works, which is multi-agents. You could have many, many different agents, and each fundamental agent actually follows the same process as the previous three or four different slides that I explained in the past, where it could be taking in structured and unstructured data, the same stuff, which is text, documents, images, audio, and so on and so forth. And each one of those agents could be taking those inputs. It could be working hand in hand with other agents. So you see that description of agent one through agent X, and each one of those agents could be using a particular LLM for itself, either a model one, model two, model three, or model X, and making its own decisions. And each agent could be providing outputs, and the other agent could be taking other inputs, and they would all be working as in consolidation to provide the different goals and services back to the users. Now, if you translate this to like a business process or business process office or a BPO office in the backend of any kind of like organization, this is exactly what happens, which is somebody works on certain task, hands over the task and leaves the task for another task for some other human. And that other human takes the output task from human one and works on that output task, does his own thing and hands it off to somebody else. Now agents can do it for you. And that's essentially AI agentic systems. And all of these agents, agent one, agent two, agent three, agent X, could be using tools in their backend to make sure that the tools is providing the backend interface for all of these agents to work hand in hand using the memory from each one of these uh, agentic interactions and using those memory to provide like better reasoning and better capability for making the entire system work. Are we there yet? Probably no. It will take some time, but we are actually making several steps right now to make sure that this kind of agentic system works in practice. And won't it be so much more helpful for all of us humans? Instead of doing too many tasks, we are doing directed tasks and using the AI agents for doing the tasks that we were doing for many, many years now. Next slide, please. And this slide, is just like a random slide that I put here to just show you the um, reason why all of these multi-agent, agentic systems could actually be helpful for us. No task today and no process today goes unmeasured. Similarly, AI agentic systems will be measured and will be observed, and the tools in the backend will actually help you and will actually provide you the measurement capability and the observability, which could be broadcasted up to your SaaS systems or to your monitoring systems or to your dashboards or to like a knock center or something saying, agent has done this, this is what the measurement has been done and delivered to you so that you can monitor these agents and say that are my agents actually working? Are my agents not working? Are they delivering the right responses? Are they not delivering the right responses? Are they doing the right reasoning? They're not doing the right reasoning. And you could actually empower the humans to say that, uh, should the agent be stopped? Should a human take over? And if the AI agentic workflow is actually working fine, what kind of ROI is it delivering for you? So some of these I'll just read out and explain like what these different tools and measurement capabilities actually provide. Latency per tool call. I mean, when an agent is actually calling like a tool, let's say an API, an iPaaS, or an RPA, does it take long time or does it take a short time? How much latency is there? It's very, very important because if you are delayed in calling that particular API or delayed in getting a response back from the API, agent is probably not that useful for you. You could do it faster yourself as a human. So this parameter should be measured and this KPI should be provided to any kind of dashboard or any kind of like knock center that you are looking at. Similarly, the other thing that you could look at is LLM call error rate. This is actually evaluating the frequency of failures in model responses to address the issues like limits or misaligned prompts. If an LLM is not delivering the right result for you in order to accomplish a certain task, that should be actually measured to say that is the LLM the right LLM that you are using, or should you use like a different LLM for accomplishing the same task? API call frequency. API calling frequency, meaning that how often do you call that API in order to accomplish a certain task? Cost per task. If it is getting costlier for you to accomplish a particular task, then you probably don't need an agent. Why do we need an agent when it's more costlier than a human? And that's a very fundamental criteria because if the human is doing the task much faster than an agent, you certainly do not need an agent for doing the same task that a human is doing. Couple of other parameters that we would probably like monitor and look at is again mentioned in this particular slide, which is um, tool selection accuracy. I also mentioned in the previous slides that AI agent is actually figuring out which tool to use. Now, if the agent picks a wrong tool, then certainly you don't want to use that agent because it's picking a wrong tool all the time. I mean, if you're striking two stones to create a fire, and now your agent is actually saying, I'm going to use two pieces of wood to strike a fire or create fire. Suddenly, striking two pieces of wood is probably not the right tool to create fire. Using two pieces of stone is probably the right method to use for creating fire. Steps per task. So if the agent is taking lots of time to accomplish the task, certainly the agent is figuring out by itself that breaking down the tasks to the very minute tasks that it needs to use to accomplish that particular task. And certainly that agent, even though it's doing it methodically, is probably not the right agent for you to put into production or put into real life for accomplishing that particular task. So don't use that particular agent. Agent wait time. If the agent picks up and decides, you know, after a long time that this is the agent that needs to be put into practice, suddenly you have not done the right goal. So all of these different parameters should be kept in mind. There are many, many other parameters, KPIs that you probably need to use. And certainly an observability system actually makes much better sense because it provides all the integral data and the internal data to help you decide which agent to use in practice. So I leave you all with this particular notion that agents, yes, we are living in an agentic world today. 2025 is the agentic year. All of these KPIs are very, very useful. So make a decision for using the right tool for the agents to make sure that you are using the right tool and empowering the agents to make the right decisions for yourself. I end this at this particular slide. If you have any questions and answers, be feel free to email, and I'll be happy to answer your